Hi students. Now the first problem in ray optics for the competitive exam. The radii of curvatures of the faces of a double convex lens. They are 10 cm and 15 cm respectively. Its focal length is 12 cm. So the refractive index of the glass lens is to be determined. So one of the four options are given. So first of all, in such problems, understanding is very important. Quickly you will have to note down what are all the given values correctly. So what type of lens it is? It is a double convex lens. Both the surfaces are convex. They have a 10 cm and 15 cm radius of curvature. You can see here it is not symmetrical. Okay, the left side is having a radius of curvature R1, and R1 is measured along the direction of light. Is it not? So R1 is positive, and R2 is measured in a direction opposite to the direction of light. Therefore, R2 is negative. Are you all understanding this? First of all, why R1 is positive? Because it is measured from left to right along the direction of light. So R1 is positive. So what are the given values? First, R1 is equal to plus 10 cm. Then when you want to measure R2, you are proceeding in a direction from right to left. That is in a direction opposite to that of the light. So the radius of curvature R2 is minus. It is given as 15 cm. Okay, minus 15 cm. Then for a double convex lens, its focal length is 12 cm. So convex lens means it is a converging lens, is it not? Therefore, its focal length is equal to plus. It is positive. Purposely I am writing so that you can understand easily. So this is a plus 12 cm. Okay, fine. Now what is the medium on the left side of the lens is air. And what is here? The lens is made up of glass. So the first medium is air and the second medium is glass. Therefore, the refractive index of the first medium is equal to the refractive index of air, that is taken as 1. Understand? And the refractive index of the second medium is taken as refractive index of the glass, that is taken as mu. That only is asked here. We have to find that only. Okay, the final question is what the refractive index of the glass lens is. We have to find out. That is mu2 we have to find out. So from lens maker's formula, 1 by f is equal to mu2 by mu1 minus 1 into 1 by R1. Okay, 1 by R1 minus 1 by R2. So this is the expression we are supposed to write. So the focal length, 1 by focal length. So this is equal to 1 by, what is the focal length given here is 12. So 1 by 12 is equal to, inside the bracket, mu2 is equal to mu glass. That is equal to mu. So this is mu divided by mu1 is 1 for air and minus 1 into, what is R1 here is plus 10. So this is 1 by 10 minus, here there is a minus sign, and this is a minus of minus 1 by 15. Okay, minus of minus 1 by 15. Now 1 by 12 is equal to, okay, this is equal to mu minus 1 into 1 by 10. Okay, 1 by 10 plus 1 by 15. So in the bracket, the LCM of 10 and 15 is 30, that is 30. So 1 by 12 is now equal to mu minus 1 into 30 is the LCM. So this is 3 by 30 plus this is 2 by 30. So this is 3 plus 2 divided by 30. So 1 by 12 is now equal to mu minus 1 into 5 by 30. 5 by 30. So this is 30 is divisible by 5 6 times. So 1 by 12. Therefore 1 by 12 is now equal to mu minus 1 into 5 by 30 can be written as 1 by 6. Okay. Therefore, what is mu minus 1 equal to? Mu minus 1 is now equal to 6 by 12. 6 by 12. So, this is equal to 1 by 2. Therefore, mu is equal to 1 by 2 plus, this is coming right as a 1. So, 1 plus half is 1 and half. That is 3 by 2. So, that is equal to 3 by 2. Or mu is now equal to 1.5. Okay, mu is equal to 1.5. So, which of these options you see here? Option D is 1.5. Therefore, option D, okay, is the correct answer. So, whenever you do such problems, carefully you will have to read the given statements and you have to write the information correctly and substitute in the relevant formula. So this practice will come only if you do similar type of problems. Many problems like this you will have to solve. I hope you must have understood this problem well.